Hello everyone. Sir Isaac Newton is known to all of us for the story of the falling apple and the discovery of gravity. He discovered the three laws of motion which answer many questions we have about our day-to-day life. He wrote the three laws of motion in his book Principia Mathematica. These laws simply talk about the moving objects, or objects that are not moving, or objects that move because other objects move, or objects that move because they react to some force in the opposite direction. Okay, maybe that covers almost every kind of motion around us. It is very important to understand and acknowledge the relevance of Newton's laws of motion in our daily life. A lot of our day-to-day activities are governed by these laws. The fun part about this video is that you will learn Newton's laws of motion yourself in the form of interesting activities. In this video, we will learn about the concept of mass, difference between mass and weight, inertia, and Newton's first law of motion. In order to understand Newton's first law of motion, we have to first understand the concept of mass and inertia. We will start with mass. Newton said that it was a particular property of objects that decided how and when it moves. That property is its mass. Mass is basically the atoms and molecules packed inside an object. When we want to know the mass of something, we put it on a weighing scale. But do you know that weighing scales don't really measure mass? They calculate the weight. Mass is simply the matter. We seem to measure mass and weight both in kilograms, grams, milligrams or pounds, but actual measurement unit of weight is Newton. Since the value of gravitational acceleration is constant all over the earth, we simply measure weight in the units of mass. Look at these rocks. Which one's heavier? This one or this one? Let me check. Okay, this one seems heavier than this. But as a scientist, a qualitative answer is not good enough. I need to know exactly how much heavier it is. Now, on a weighing machine, let me weigh both these rocks. Now, quantitatively, I know how much heavier this one is than this one. This answers my question. Here, we have 1 kilogram of cotton and 1 kilogram of onions. Can you tell whether the mass of both of them is equal or not? We can see that the mass of 1 kilogram of cotton and 1 kilogram of onion is obviously the same, even though their volumes are very different. Mass gives an object inertia. In the next activity, we will learn about inertia. Here, we have two plastic bottles. Both of them are filled with water. Let me place them one on top of the other with a paper strip sandwiched in between them. Now, if I strike this strip hard with my fingers, what do you think will happen? What do you observe? Magically, the strip is in my hands and the bottles are standing on top of one another. Bottles are standing like this because of inertia. According to Newton, the more the mass, the more will be inertia. Inertia is the tendency of an object to retain its state of rest or uniform motion until something external tries to change that state. When we flicked the strip, it fell down in motion while bottles remained at rest. Here we have different types of balls. Can you tell what will be the inertia of these balls? We can compare the inertia of these balls only after knowing their masses. Ball which is heavier will have more inertia as compared to the ball that is lighter. Similarly, like in the previous example, the bag of 1 kilogram of cotton and 1 kilogram of onions will have the same inertia. Now we will talk about Newton's first law of motion. Mass of an object decides inertia of an object. But if we apply force on that object, its state changes from rest to motion or motion to rest. Let's understand this with the help of an activity. Here we have a glass, a plain plastic plate and a plastic ball. Now I will place this plate on top of the glass and balance this ball in the center of the plate. Now I will flick the plate with my finger with one clean motion. What do you see? The ball doesn't move with the plate. It falls straight into the glass because of gravity. We observed that an external force on the plate threw it off the glass, but the ball stayed at rest. This is Newton's first law of motion, which states that any object will remain in the state of uniform motion or the state of rest unless an external unbalanced force acts upon it. External unbalanced force here was the flicking of the plate. The plastic plate at rest changed its state of rest and went into motion. Now can you tell, why do we jerk backward when a bus starts moving? We are in stationary motion in a bus, so our body tries to retain its state of rest. That's why we feel a jerk backward when the bus starts moving. Hope you enjoyed this video and learnt Newton's first law of motion. Join with me in the next video to learn about Newton's second law of motion. Thank you.